All right, so in this video, I'm going to be talking through page 20 of the notes packets. This is where we have some practice for amortization. These are IB style questions, so these are going to help kind of bridge the gap towards what our practice in class looks like and what you'll be seeing on your test and on the IB exam. All right, so it says give all answers to 2 decimal places unless otherwise stated. That's because we're working with money. On January 1st, 2024, Emily invests $600,000 in a savings account, which pays a nominal interest rate of 4.5% compounded annually. Determine the amount of money that will be in the account after 12 years. Well, so we can use our formula or we can use the calculator. I'm going to be using the application on the calculator. You do whatever is most familiar to you. For our present value, we have 600,000. Our interest rate is 4.5%. Our K is just 1, right? Compounded annually. And our N is going to be 12 here. So if we go to our calculator, we can avoid clicking on the Temu app ad. And then we can go finance, you can go TMV solver. N is going to be 12. I is 4.5. Present value is 600,000. Payment is nothing here. The future values that we're trying to find, and PY and CY should be 1, so we can just go put, this is what happens when you forget to do negative on the present value. Then you hit alpha enter, and we see that that's going to accumulate to be 1,017,528.86. So that's going to be 1,017,528.86. After these 12 years, Emily is planning to retire and place the money that she has saved into an annuity fund, which pays a nominal interest rate of 3.5% compounded monthly. Emily wants to withdraw money from this account at the end of each month. Calculate the amount of money Emily can withdraw at the end of each month if she wants the money to last for at least 18 years into her retirement. All right, so here we got to figure out. So first of all, PY and CY are going to be 12 here. All right, so we're working with monthly compounding and monthly payments. We don't know the value of the payments, right? That's what we're trying to find. We know that the present value is going to be that amount that she has, so negative, right? We'd put into the calculator as a negative 528.86. And the future value we can put as 0 because you want to see until it is exhausted. Then we just have to worry about that N, which is the number of compounding periods. That's going to be 18 times 12. $216. All right, so now I think we have all the information that we need here. So I'm going to go apps, finance, TMV solver. I'm going to make the present value negative 1,017,528.86. The interest rate here is 3.5%. So interest rate is going to be 3.5%. 3.5%. Payments, what we're trying to solve, future value down to 0. PY and CY should not be 216. They should be 12. And N should be 216. All right, now we can go payment, alpha, enter, and see that that will be monthly payments of $6,356. So $6,356. $2,000.11. Find how many complete months counted from January 1, 2036 it will take for the balance of the fund to fall below $50,000. So so that is when she's retiring. So how many months from the time that she retires until it falls below 500,000? Well, this is straightforward. Right now we can leave the payment as is, and we can change the future value from 0 to 500,000. And then all we have to do is go back here and recalculate the n. You can see that's going to take 127 months. So 127 months, that's about 10 years for the balance to fall below 500,000. All right. If we go down here, we get Charles plans to invest in a retirement plan for 30 years. In this plan, he will deposit 1,000 Great British pounds at the end of every month and receive 6.5% interest rate per annum, compounded monthly. Find the future value of the investment at the end of 30 years. Give your balance to the nearest pound. All right, so we have 1,000 pounds. So our PV is 1,000. The interest rate, 6.5. Oh, sorry, the present value is not 1,000. Invest in retirement. Hit the payment. PMT is going to be negative 1,000. I is 6.5%. So PV is 0. Future value is what we're trying to find at the end of 30 years. So N is going to be 360, right? 30 years times 12 months a year. And PY and CY will both be 12. All right. So N is 360. That is 6.5. Is that correct? Yep. Present value of 0. Payment of negative 1,000. Future value is what we want to find. We can see that's going to be 1,106,178. So 1,106,178. All right, after the 30-year period, Charles will start receiving regular monthly payments of $1,500. Count the number of monthly retirement payments it will take. Calculate the number of years it will take Charlie's monthly retirement payments to match the total amount originally invested. All right, so if we want to think about how much was originally invested, but we have to think about that's $1,000 a month times 30 years. So the amount of money originally invested is 1,000 times 360. So that's 360,000. So original investment, 360,000. If he's drawing that down at a rate of 1,500 per pound or per month, then 36,000 divided by 1,500, so 360,000 divided by 1,500 is 240. So that is 20 years.